In traditional cloud, we talk about CPUs, storage, networking, memory. But when it comes to AI, we mostly talk about GPU capacity and token generation speed. What metrics are missing from that conversation? The ones that actually matter for real world AI agent performance.
Yeah, no, this is kind of a key optimization that we've been looking at. And again, as we've been working with customers, is that they're building these agents. The GPU is really important, and we've been deploying a lot of the Blackwell GPUs and the speed of those GPUs. So time to first token, the throughput, the number of tokens they can generate per second. Those are incredibly important metrics that we're seeing that customers are optimizing for. But for these applications, an agentic application, often what we're seeing is up to 90% of the overall task execution isn't on the GPU, so isn't kind of generating tokens. The majority of that time is actually in the tool calling portion of the agent. So calling out to these third-party systems, calling external APIs, pulling data into, pulling in context, pulling in real-time information that's needed to generate the answers. This is what's actually generating the majority of the end-to-end latency for the task to be successful. And so optimizing for the end-to-end system is what's important. So GPUs are a really important part, but often what we're seeing is there's a really big portion of the end-to-end time that's not on the GPU at all. So you can have the most powerful, fastest model running on the latest GPU, but if your compute is in the wrong location, if you don't have good connectivity out to the tools, if you're not running with good connectivity to storage and other data systems that you need, your system is still going to be slow and isn't going to meet the expectations of the users.
Akamai has been talking about a compute continuum for a while now. What does that actually look like in practice, spanning from centralized data centers all the way to the network edge when we talk about AI?
This is a big optimization problem. So something that we've been working on is what we call our AI Grid Orchestrator. So NVIDIA's talked a lot about their kind of AI Grid reference architecture. So as we move from kind of centralized token factories to kind of these real-world systems that can deploy applications for kind of real-time token generation. Having the ability to have that in a grid, so distributed infrastructure, is important. But that needs orchestration. So you've got all of these different locations where you can run workloads. And what we find is there are certainly very large models that need to be deployed on powerful GPUs, often clusters of GPUs. Makes sense to have that in more centralized locations. So you don't want to have those deployed in hundreds of locations. It's very hard to maintain utilization of highly distributed clusters of GPUs like that. But then what we see is for the CPU where the agent is running, where we're deploying sandboxes, where we're spinning up containers to kind of run kind of code execution, that's something that is isolating sandbox to an individual user, an individual session, and it makes sense as we look to optimize end-to-end performance, manage cost, for that to be close to the end user. That's where what we're seeing is the separation between CPU and GPU is often beneficial in these types of distributed systems. We can place those different components of the application in the right physical location to drive end-to-end latency down, and then also make sure we're driving effective utilization of that infrastructure. And then key requirement for the orchestrator is to coordinate between the CPU and the GPU and schedule the execution effectively across those different components of the infrastructure.